Hello, my name's Annika Nichols. Today we're going to be going over functional groups. We're going to start with some of the basics and then we're going to work on identifying and naming functional groups. And then towards the end, we'll go over properties of functional groups. Okay, so let's first talk about what is a functional group. So, a functional group is a specific group of atoms that gives a molecule its characteristic chemical properties and reactions. So, why are functional groups important? Functional groups are important because they help us determine how molecules are going to react. They also help chemists name compounds, and then they also help us figure out some physical properties that a compound might have, like its boiling point, acidity, or solubility. I'm going to go ahead and apologize for any squeaking that you might hear in the background. That is my puppy. But before we can get started on functional groups, it's easier if we can understand a little bit of background first. So, right here, what we have pictured is a carbon backbone. And this is what we look at a lot in organic chemistry. So, the functional groups are going to attach to this carbon backbone. And they kind of, that's what determines the different properties of the molecule. So, we can have two carbon backbones that have the exact same number of carbon and look the exact same, but the properties can be completely different based on the different functional groups that attach to it. So now we're going to look at some helpful tables. The table that I believe is on your left, it's the tall skinny one, is one that I actually use all of the time when we're doing homeworks, labs, anything like that. I really love this table because it gives the functional group a structure and examples. So if I'm not quite sure what does that structure look like, I can always look up that example on Google and kind of find out and piece together what it's talking about. And then I can also look at the explanation, and that can be a telltale sign of what that functional group really does look like. Okay, so we're going to go through this table and kind of look at these functional groups in different settings and different groups, because I think that, at least for me personally, that has been the easiest way to memorize them and understand them. So first we're going to look at alkane, alkene, and alkyne. These are dependent upon the number of hydrocarbon bonds that we have. Alkane is going to be a single hydrocarbon bond, alkene is going to be a double, and then alkyne is going to be a triple. The easiest way for me to remember these three, because they are very similar words, is that the A, the E, and the Y are all in alphabetical order and numbered as 1, 2, 3, dependent upon how many hydrocarbon bonds they have. Next, we're going to jump down and look at the alcohol. I find this one very easy to spot because we just see that hydroxyl group, that OH, attached to the carbon backbone. And ether is another easy one to spot because we see an oxygen bonded to a carbon. The aldehyde is when we're going to have a carbonyl group, a CHO, attached to the hydrogen. A ketone group is going to be a carbonyl that has carbon attached to both sides. An ester is going to have a carbonyl adjacent to an oxygen atom. And then grouping these two together, amine and amide. An amine contains an amino group, and then an amide contains a carbonyl bonded to an amine. Okay, so here are kind of the three things that I like to look for when I am trying to identify, pick out what type of functional group I'm looking at. So I first like to look and see if the oxygen is present. This tells us that it could be like an alcohol or carbonyl, an ester, an ether, any of those. And from here with my chart, I'm kind of just doing process of elimination. Also look at the nitrogen. This could tell us if it's an amine or an amide. And then we can also look at the carbon bonds, see if we have single, triple, double, tell us if it's an alkane, alkene, or alkyne. I believe that one of the easiest ways to do is to practice. So we're going to do some practice problems to help put in perspective what these functional groups look like. On the left-hand side of your screen, we see a carbon bonded to another carbon with a single bond, so we know that this is an alkane. And then somewhat similarly on the right, we see two carbons bonded with a double bond, so we know this is an alkene. Like I said earlier, the easiest way for me to remember this is go alphabetical order. Following suit, we're going to look at this triple bond between the carbon and the carbon. That's going to tell us that this is an alkyne. Okay, and then on the right, we see this beautiful hydroxyl group. That tells us that this is an alcohol. Then here on the left, we see a carbonyl, and we see that next to or adjacent to an oxygen, and that tells us that we have an ester. And then on the right, we can see this beautiful amino group, and that tells us that this is an amide. For video's sake, these are all the practice problems that I included, but if you would like to see more practice problems, I will definitely like to share them with you guys. Since this is one of the more basic topics in organic chemistry, it was one that I practiced a lot because I wanted to make sure that I had it down. So I have a lot of other helpful YouTube videos, or Khan Academy is one that I've used a lot for practice problems. So if you are interested in that, please let me know, and I would love to share those resources with you. However, for video's sake, we are going to go ahead and move on and jump into some of the properties that we see when we see functional groups. The properties that we're going to be talking about are polarity, solubility, boiling point, and reactivity. So understanding these properties can better help us understand compounds, especially when we know that a functional group has certain properties. So for example, when we're talking about polarity, polar molecules dissolve better in water. So we know that these are going to be things like our alcohols or our amines. Things that are nonpolar, like our alkanes, are not going to dissolve as well in water. As most of us know, hydrogen bonds increase solubility. So things like our alcohols or our amines are going to be water soluble. And then things like our hydrocarbons are going to be poorly soluble. So a property that we can look out for boiling point is that we know hydrogen bonding increases something's boiling point. So functional groups that are like our alkanes are going to have a lower boiling point, where alcohols are going to have a higher boiling point. And then functional groups also affect reactivity. For example, alcohols can be oxidized and alkenes undergo additional reactions. Understanding these properties really helps scientists to better understand and to group together compounds. Thank you for watching my presentation. If you have any questions or anything that I didn't really cover very well, or you want more example problems, please comment, and I would love to further what I can inform you guys, or give some more practice problems. Thank you.